right. Okay, so for posterity, this is the exam 1 review for Math 114 Trigonometry. We are currently in fall semester 2023. Usually these videos get remade every semester, but in case this one gets reused later, now it's there and it's on the internet. It was more for the video than for any of y'all here. So let's just do this. Question number 1 on the exam itself is exactly this question. This is just copy and pasted either from the practice exam onto the exam or from the exam onto the practice exam, depending on which way you want to view that. But this is the first question. It will be identical to this. All you have to do is recreate the entire unit circle from memory. That's it. So there are a collection of 16 points on the unit circle that I've requested that you memorize. And the question is worth 16 points. You can probably figure how the breakdown of that point distribution works. The thing that I'm asking for on each point is the exact radian measure and the exact x and y coordinates. So as an example, you should write something like pi over 6 and square root of 3 over 2, but make it more legible, and 1/2, because that is the point at pi over 6. Or if I were to do just another one randomly, how about 2 pi over 3? And then this one is at negative 1/2, positive square root of 3 over 2. All right, so that's just 2 of the 16 points. You'll want to put them all on there. One of those points has maybe 2 angle measures, and let's say include both, but as long as you have one, you'll get it either way. All right, so an angle measure of 0 radians is in the exact same position as 2 pi radians, measured in standard position. So put 0, I mean, honestly, it'd be best if you put both. As long as you have at least one, you'll get credit. But yeah, put both. It'll be best for everyone if you do. And so again, all I'm asking for are the radian measure on each one. And that means I don't care if you put the degrees or not. You can if you want to, if it helps you out. Like, for example, this one was 30 degrees. This one is at 120 degrees. Put it on there if you want, but it's not necessary. All you'll get graded on are the angle measures and all of the points. Again, collection of 16 points, problem's worth 16 points. It's not a coincidence. But moving on, I had to make one correction to the practice exam because technically question 1 wasn't solvable with the way that it was initially written out. So sorry if you went ahead and did that. Why is there a random 732 there? I don't know. Apparently I hit buttons. Oh, that was the code to sign into the projector. All right, well, that'll be fun for anybody looking at it later. Okay, right. So I made a quick correction to problem number 2 here. It used to say cotangent is equal to 6 and sine of theta is equal to 1 over 9. But as it turns out, there is no triangle that will work for. So I accidentally overdetermined the problem. So I made a quick edit and just changed it to say that tangent of theta is less than 0. And sine of theta is 1 over 9. Use some trigonometric identities to find the exact value of cosine theta. And let's give that thing a shot. So let's put together some stuff that we know. We have sine of theta is a positive value. You know, it's positive 1/9 specifically. And we know that tangent of theta is less than 0. I'm hoping to figure out what quadrant my angle is located in. So if I do my quick sketch of the coordinate plane, say that I know sine theta is positive, that's got to happen in quadrant 1 or in quadrant 2. Sine's the y values, so it should be positive in the top half of the coordinate plane. If tangent theta is negative, that'll happen in quadrants 2 and 4. And I think I can see that of those options, the only spot where they overlap is quadrant 2. So my angle must be in quadrant 2, which means that the cosine values are negative in that quadrant. So if sine of theta is positive and tangent theta is negative, that means that cosine is also negative. So just to remind myself of that, I'm going to put a negative in the answer box so that I make sure that at least that part of my answer is correct. Now to actually get the numerical value of cosine, the only thing I know outside of the plus or minus sign of tangent is that sine of theta is 1/9. So if I were going to use a Pythagorean identity to relate sine and cosine together, rather if I was going to use a trigonometric identity to relate sine and cosine together, I would probably pick the Pythagorean identity. Namely, cosine squared is equal to 1 minus sine squared, which in turn is 1 minus 1/9 squared. So on this spot right here, I just want to discuss one quick thing. We know that sine of theta is 1/9, not that theta is 1/9. All right, so there's an important distinction between the two. The angle is not 1/9 of a degree. I know that the opposite side divided by the hypotenuse works out to 1/9. Which means when I'm substituting that 1/9 in, it's not sine of 1/9. It is that the entire sine of theta gets replaced with 1/9. So it's theta is not quite like x, where I just substitute in directly for theta. I'm replacing all of sine theta with 1/9. So once the 1/9 comes in, sine of theta is completely out of the problem. So just a heads up, because that might be important tomorrow. Right, so I've got 1 minus 1/9 squared. If I square 1/9, I should get 1/81. And then since I want to add, or rather subtract a couple fractions, I'm going to change 1 to have a common denominator. So 1 is the same as 81/81, meaning I can have this as 81/81 minus 1/81, which simplifies to 80/81. So I want to take the square root of that. So cosine should be the square root of 80/81, but keep in mind, anytime we take the square root of a variable, cosine theta here counts as a variable, I should have a plus or minus show up. And we already did the legwork to deal with this part. We know that cosine should be negative because we're in the second quadrant. So out of my plus or minus option, I should take the minus. And then I'll simplify the rest of that fraction. So my denominator is a square number, so I can just take its square root. Square root of 81 is 9. Up in the numerator, I need the square root of 80. 80 itself is not square, but I can break it down into the product of a square and non-square factors. In particular, 80 is equal to 16 times 5. So I can separate that square root into 4 times the square root of 5. didn't leave myself enough room for a negative sign. So 4 square root 5 over 9 would be the completely simplified answer here. So 4 square root 5 over 9. Quick note then on what kind of an answer I'd expect. If I want a completely simplified answer, that would be this one, and I'll specify that I want my answer completely simplified. If I don't say specifically that you have to simplify the whole thing, you could leave it at square root 80 over 9, but you should at least take the square root of any square numbers, as well as reducing, like this does tell you that you should be reducing fractions, so do at least that. But yeah, so it's here. Chances are on the written portion, I'm not going to give you something that's that complex that you need to simplify. However, on a multiple choice section, if I'm giving you a bunch of multiple choice answers, I am going to be simplifying my answer all the way down to here. So at the very least, be able to recognize how I would simplify all the way down, even if you don't need to do that exactly on the exam itself. Let's go see what chat is saying. 81 over 81. Yes, that is it exactly. It's equal to 1. Thought it might have been where we were hung up. Okay, so that's problem 2. All right, problem 3, going back to the unit circle, and also it looks like some coterminal angles. Solve the following based on what we know off of the unit circle. So keep in mind that if I look at all the angles I've got here, or at least the first 2, negative 4 pi over 3, 17 pi over 6, neither of those are directly angles that I've asked you to memorize off of the unit circle, but they are going to be coterminal to angles that are. So just as a quick reminder, coterminal angles are any 2 angles that are exactly a circle apart. Right, so if we're looking in one direction, spin in a full circle, we'll be back to looking in the same direction. That's coterminal. And coterminal angles all have the same values for sine and cosine. So we'll use coterminal angles to figure out each of the solutions in problem 3. And just because I saw a question in chat, back up here, why did I pick quadrant 2 and not quadrant 4? My 2 bits of information did not overlap in quadrant 4. They only overlapped in quadrant 2. Specifically, sine of theta is negative in quadrant 4. And I was told that sine of theta is positive. So it cannot be quadrant 4. Must be quadrant 2. But I digress. Back to this one. I need coterminal angles here. So I'm going to add 2 pi to negative 4 pi over 3. Negative 4 pi over 3 plus 2 pi, where 2 pi is 6 pi over 3. And get 2 pi over 3. Meaning cotangent of negative 4 pi over 3 is equal to the cotangent of 2 pi over 3, which is 1 over the tangent of 2 pi over 3, which means that this is 1 over negative square root 3. So tangent of 2 pi over 3 is something you'll need memorized from the unit circle, or you can solve for it real quick. But I get 1 over negative square root 3. Then I'm going to simplify that fraction, or rather rationalize that fraction. I do not want a square root or an irrational number in the denominator. So multiply top and bottom by the square root of 3 to get negative square root 3 over 3. And that's the answer I'd be looking for. Up next, I want the sine of 17 pi over 6. 17 pi over 6 is more than 2 pi. So I've gone around a full circle once already. So I'm going to back that up to get it between 0 and 2 pi. So I'll subtract 2 pi again. 2 pi is the same as 12 pi over 6. Leaving you with 5 pi over 6. So the sine of 17 pi over 6 is the same as the sine of 5 pi over 6. And from the unit circle, we know that that's 1/2. Positive 1/2 because I'm in the second quadrant. So that'll do it there. The last one, I don't need a coterminal angle for. 7 pi over 4 is something we know off of the unit circle, so I can go straight to an identity, namely that cosecant is 1 over sine. So 1 over sine of 7 pi over 4 is 1 over negative root 2 over 2. Right, into the fourth quadrant, sine is negative there. It's one of the over 4s. All the over 4s are root 2 over 2. Both sine and cosine. And I've got 1 over a fraction, which means I just want that fraction's reciprocal. So negative 2 over the square root of 2. I'm going to rationalize that again, just like we did above. So negative 2 square root 2 all over 2, which simplifies to just negative square root 2. There we go. Fix some of the work so it's a little more legible. Cool. So negative square root of 2. So I'm not asking you to specifically memorize the values for secant, cosecant, or cotangent. You can if you want to, because it might help out a little. But I won't ask for those from memory, but I will ask you to be able to solve for them using just some of the basic identities. Hi, what's up? On this exam, yes, you'll be given the trig identities. Yep, so everything out of worksheet 2, there's that collection of 3 categories of identities. I think there's 14 of them in total, but I've probably said a different number every time I've quoted the number of identities. But either way, all of them that are on worksheet 2, you'll be given on the exam. It'll be the very last page, and you can tear it off and have it with you if you want to.
Could you say the all of the worksheets that are going to be on the exam, please?
All right, up next then, problem number 4. Given the exact value, or blah, 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 try again. Given the following right triangle, state the requested identity and then find the exact value of that thing. And this one tells us specifically we need to be simplifying all of our radicals. So on this one, I would care whether or not you simplified your square roots. If it comes up, which spoiler it actually won't. So secant of 90 degrees minus alpha. So this is an identity that you'd be given, but you'd need to know to look on that last page to find the correct one. But anytime we've got 90 degrees minus alpha or pi over 2 minus theta, all of those are the cofunction identities. So in particular, this thing must be the cosecant of alpha. Right, because cosecant is the cofunction of secant. So if this is our angle alpha up here, notice that it's listed for us. 90 degrees minus alpha is that lad down there. It's the red one. For completeness' sake, I'll put my right angle indicator there. But we were told in the problem that it is indeed a right triangle. And yes, you are correct. It is worksheets 1 through 4 on the exam. Okay, so I am missing one of my side lengths. So I'm just gonna give it a label of y. I can call it whatever I want, but I chose y. If I want cosecant of alpha, that means I'm going to need my hypotenuse over my opposite side. The hypotenuse is 11. I already know that. But the leg that is opposite alpha is this currently unknown side y. Since square root 57 is adjacent to alpha. So y is the opposite side, meaning if I want to know the cosecant of alpha, I'm going to need the Pythagorean theorem. I need to know what y is. So going to the Pythagorean theorem, I'll have the square roots of 57 squared plus y squared is equal to 11 squared. Don't forget that the hypotenuse is always the side that goes by itself in the Pythagorean theorem. Slide that out a little bit. Which means y squared is equal to 121 minus 57. I believe if I do that subtraction real quick, 121 minus 57 leaves me with 64. And so finally, y is 8. Meaning that secant of 90 minus alpha, which is the same as cosecant of alpha, is 11 over 8. 11 over 8. So the triangle that we're looking at here, this triangle was not placed it's not in the coordinate plane, it just is a triangle. It means also it's not a reference triangle or anything like that, which means that we're considering all the side lengths to be positive. Right, so we're not like trying to assign, a positive or a negative to y based on what quadrant it's in. This one is just a triangle, not in the coordinate plane again, just a regular old triangle. So we don't need to worry about negative sides. Yeah, so 11 over 8. All right, then a quick multiple choice section. This will probably be more relevant for the online part of the exam than it will for the in-person part. But we should look at it anyway. So given some information, namely cotangent is less than 0 and secant is greater than 0. Put it in, I usually do red for quadrant locations. So cotangent, if it's negative, that means I'm in, oh boy, that's not good. Well, we've lost the whole practice exam, so give it a second while it comes back. Hey, there we are. Well, no, maybe not just yet. Somehow we got back to the beginning. Come on, I believe. Okay, here we go. And of course now, hey, really? Really? All right, well, I can at least go check chat while this is breaking itself apart. No, we're gonna come back to more of the in-person questions. It's just that I believe that on the in-person part of the exam, there are not any multiple choice questions because I put them all in the online section or the online portion of the exam. Okay. Now, Take a deep breath. Hope I can write on my tablet right now. So if cotangent of theta is less than 0, okay, that puts us either in quadrant 2 or 4. Those are the two spots where cotangent's negative. If secant is positive, that'll be the same as cosine being positive. So either quadrant 1 or 4. And then the quadrant where those two colors overlap is 4. So we must be in quadrant 4 on that one. How many questions are on the exam? Between 4 and 12, I think. Also depends on how many questions you count the unit circle as. I think D2L counts it as 16 questions, but I'd count it as 1 question. So the number gets a little inflated. All right, let's take a look at this next guy. Finding an angle in standard position that measures -8 radians. Which quadrant is that in? Well, -8 is somewhere, I've gone backwards a circle or two. In particular, I know I must have gone backwards more than a full circle, since one full circle would be about 6.28 radians. So I'm going to need to find a coterminal angle here. I'd like one that's positive. If I only add one circle here, I'm still going to end up at a negative number. So I'm going to add 2 full circles in order to get to my positive number. If I do that, should hopefully get 4.56. And 4.56 radians is in quadrant 3. So the terminal side of an angle that measures -8 radians from standard position is in quadrant 3. And again, I'm going to know that it's in quadrant 3 because 4.56 is in between 3.14 and 4.71, which are pi and 3 pi over 2 respectively, or at least very close to those values. So those values rounded to 2 decimal places. Oh, but that's accurate enough. I just need to know what quadrant I'm in. Less than 4.7, more than 3.2. That's in quadrant 3. Looks like they're handling it. Okay, 2 coterminal angles for -7 pi over 15 are some of the following. If I were to guess how I'd have written this question, I'd probably give the coterminal angles that are 1 circle forward and 1 circle backward from this one. So I'm going to take my angle of -7 pi over 15. And I'm going to add 2 pi and subtract 2 pi and see where we get. So adding 2 pi will be the same as adding 30 pi over 15. Just get a common denominator so that I can add those up. Gets me to 23 pi over 15. If I look 1 circle backwards, so subtract 2 pi, I end up at -37 pi over 15. So I'm going to hope that those 2 angles show up. Scanning my multiple choice options, it looks like they do. Option E. So I'd pick that one. Cool. All Right, and then I want a reference angle for 37 pi over 30. So step one, figuring out what quadrant we're in. So I need to look at 37 over 30. 37 over 30 is a fraction that's more than 1 but less than 1.5. Right, hey, come on. 37 over 30. More than 1 but less than 1.5, which means that we're in quadrant 3. Quadrant 3. Meaning that the reference angle for any angle that is in the third quadrant is theta minus pi. Or 37 pi over 30 minus 30 pi over 30. Since pi as a fraction over 30 is 30 over 30 times pi. So 37 minus 30 leaves me with 7 pi over 30, which was option A. So a couple of quick questions from chat. First, can I post this after class? You can have the completed version to compare to. Yeah, actually all of everything that I do in class posts itself live while I'm doing it. So this is just in the class notes, the link that's on D2L. It's already there. So it'll be there. It's available now. In stores now. Second, how did I know that it was in quadrant 3 from that? I am looking to place 37 pi over 30 between two of my quadrant dividing angles. And so I know that 37 pi over 30 is in between pi and 3 pi over 2 because that coefficient, the 37 over 30, that's more than 1 but less than 1.5. It's more than 1 and less than 3 over 2. So that's how I knew it was in quadrant 3. Next, okay. Keep on tracking. We got like 4 more questions. We got like 5 more. Crap. Okay. Given that the radius of the Earth is approximately 3,960 miles, find the distance between Dallas, Texas, with a latitude of what's given, 32.79 degrees, and Omaha, Nebraska, that's at a latitude of 41.26 degrees. Yeah, cool. So these are 2 cities located on the edge or on the They are located on Earth, which is a globe. Come on, there we go. Or the Earth, which is roughly a sphere. We're going to at least pretend that it is one. I'm going to draw in the equator. That'll be helpful to us. The equator is at a latitude of 0 degrees. If I measure up to Dallas, it'll make an angle of about 32 degrees with the equator. If I measure up to Omaha, it'll make an angle of about 41 degrees with the equator. So if I draw in those 2 pieces right there, I know that, yeah, let's see. This angle right here is about 32 degrees. This angle right there is about 41 degrees. But the part I really care about is just the angle that's between them. That red angle theta. That's the angle I'm really after. Because ultimately I want to get the distance between the 2 cities. And they are far enough apart that just calculating a straight line is going to not be accurate. So I need the curved line that fits along the circumference of the disk. So that means I'm going to need to calculate an arc length. So I'm looking for S equals R theta. But keep in mind that in that formula, it is particularly important that our theta be measured in radians. Angles got to be measured in radians for this thing to work. So step one, it's going to be finding out what my angle is. Then step two is going to be to convert that thing to radians. So starting with just figuring out what theta is. It's the difference between my two latitudes. So 41.26 minus 32.79. That looks like 8.547. And then I can plug that into my arc length calculation. 3,960 is the radius times 8.47 multiplied by pi over 180. So I can get that thing into radians. And then plug that into a calculator. Hopefully you get 585.40. We're rounding to 2 decimal places, that's 2. And our radius was given in miles, so this distance should be given in miles. So Dallas and Omaha are about 585 miles apart as the crow flies. Because that's a unit of measure. Okay, cool. Moving on. Right, I gotta keep moving. Medical alert helicopter is flying at an altitude of 734 feet. The helicopter emergency crew sees an ambulance at an angle of depression of 62 degrees. Find the distance of the ambulance from a point on the ground directly below the helicopter. Awkwardly worded question, but it'll probably be equally awkwardly worded on the exam. So yeah, let's go with that. So I should draw a picture. All right, there's the ground. I need a helicopter. Yeah, that's a helicopter. He's going to be at an altitude that was given. So I'll just draw in a vertical line right here. I know that altitude is 734 feet. Where we have an angle of depression of 62 degrees. I'm going to exaggerate that angle a little bit just so that my picture looks all right. This diagram's not to scale. It spies an ambulance hanging out over there. I'll label an ambulance a little red cross sign. And what do we want? We want to know the distance between the ambulance and a point on the ground directly below the helicopter. I'm gonna label that thing with an X right there. That distance, X, is what I'm after. From here to here. That's what I want to find. And I still need to put my angle of depression on this diagram. Now, be careful. Because this angle right here is not 62 degrees. Right, so that is not our angle of depression. It's the one that shows up in the picture that we draw. It's inside the triangle, but that is not an angle of depression. So angles of elevation and depression are always measured from a horizontal line, which means to correctly label that angle of depression, I should draw in a horizontal line at my helicopter, and then label this lad right here as 62 degrees. Angle of depression. It's that thing. Cool. So now with the correctly labeled angle, now I can go after my distance. Slide you over here. If my angle of depression is 62 degrees, that means that my angle of elevation going the opposite way is also 62 degrees. Alternatively, I could also use the complementary angle theorem or complementary angle idea to say that the angle on the inside of my triangle at the helicopter is 28 degrees. But either way I slice it, I know, let's focus on the 28 degree angle. Focus on the blue one. At that blue angle, I know my adjacent side is 734, and I'm interested in my opposite side. So if I put opposite and adjacent together, that gets me a tangent function. So I should be looking at something like tangent of 28 degrees is equal to x over 734. And then I made my drawing a little bit too far to the right. So I'll slide it that way. Solve that expression or solve that equation for x to get x is equal to 734 times the tangent of 28 degrees. And that gives me a number. I got 390.27. And this is in feet. Awesome. All right, then up next. Yeah, okay. Trying to decide if the point -1/5 and 4/5 is on the terminal side of an angle theta in standard position. Is this thing on the unit circle? So keep in mind that the 16 points that you've memorized are only 16 of the points that are on the unit circle. There are actually an infinite number of them. The circle is a line made up of an infinite number of points. There are just 16 that we really care about. In general, if I want to see if a point is on the unit circle, I just have to check whether or not x squared plus y squared is equal to 1. If it's on the unit circle, x squared plus y squared is equal to 1. And if it's not on the unit circle, x squared plus y squared will be any other value. But this is the equation of the unit circle. Circle with a radius 1 centered at the origin has that equation. So I'll check this out. I've got -1/5 squared plus 4/5 squared, which looks like 1/25 plus 16/25, which is 17/25. And last I checked, hey, stop it. Last I checked, 17/25 is not equal to 1. So since they did squaring those numbers, adding them together did not get me 1, this thing is not on the unit circle. To find the exact value of secant theta, Because it's not on the unit circle, that means cosine and x are not equivalent. So x being equal to cosine theta only works on the unit circle. If we're not on the unit circle, it's not true anymore. So we would need a reference triangle to solve it. But because I'm running out of time, I'm going to add that to the notes later. So one thing I do want to cover is this one, using a reference triangle to solve a bunch of other stuff, but in a more exciting way than the last one. So given that secant of theta is negative 37 over 35, and sine of theta is negative, complete a reference triangle for that information. So if I take a look at these two bits of information, I know that secant is negative, which this is the same as saying cosine is negative. So I'm in either quadrant 2 or 3. If sine of theta is negative, I know I'm on the bottom half of the coordinate plane. So either 3 or 4. And the spot where those overlap is quadrant 3. So I should draw this reference triangle in quadrant 3. So if it's a reference triangle, I'm going to add coordinate plane or the coordinate axes to it. The angle theta that I'm interested in is that blue one measured from standard position, but the reference angle is just this red one. And I know that secant of theta is negative 37 over 35, meaning my hypotenuse is 37 and my adjacent side is 35. And because I'm in the third quadrant, I should put a negative on the 35. Remember that we're never going to put negatives on the hypotenuse. There'll always be a positive number. Which means I'm missing my opposite side. I'm missing my y side, so I'll just label it y. And I'll go to the Pythagorean theorem to figure out what it is. Hey, come back. 35 squared, or rather, negative 35 squared plus y squared is equal to 37 squared, meaning that y squared is 37 squared minus 35 squared. If you plug that into a calculator, you'll see that you're left with 144, meaning that y is the square root of 144, which is 12. But because we took the square root of a variable, we should put a plus or minus on there. And finally, we're in the third quadrant where y values are negative. So y is negative 12. And that's our complete reference triangle. Once we have this reference triangle, we can use it to solve for all 6 of the basic trig functions. We already have secants. We don't need to solve for that one. But the rest, we might want it for. This is also a question I'll need to edit. We haven't learned that identity yet. So just know that, pretend the question was just asking for cosine of theta. Cosine of theta is the reciprocal of secant. So this is negative 35 over 37. Hmm, 130. Cool. Up next, the sine of pi over 2 minus theta, that is, or rather the cosine of pi over 2 minus theta, that's sine of theta. From our circle, I want opposite over hypotenuse, which is negative 12 over 37. If we look at the part above, opposite was negative 12, hypotenuse is 37. And then lastly, I want tangent of theta squared, which is negative 12 over negative 35 squared, which is, See, 12 squared is 144. 35 squared is less than 1600, so it's 1225. Pretty sure. So we give that as our answer. And that does put us over on time, so I missed just one question. But it's the trig identity problem. So I'll add this to the notes later. So keep in mind, you get the identities on this one. It'll be maybe roughly this complex, maybe a little less complex than this one. I'll have to edit this anyway. Cool. Look at the last quiz to see a relatively similar example to the one that's on the exam. Anyway, good luck tomorrow. Or if you're watching this video at a later time, good luck whenever your exam is. Okay, bye. So I'm saying just the coefficient 37 over 30 is between 1 and 3 over 2. Those all are coming from 1 pi and 3 over 2 pi. Yes. If I had multiplied the pi in it with it.
Okay, so you're just ignoring pi.
Exactly. I thought it'd be easier to find the location if I only looked at 37 over 30 and ignored the pi.
Thank you.
So this is telling us which things are positive. All 6 are positive in 1. Sine is positive in 2. Sine is negative. Tangent is positive in 3. Negative in 4. Cosine is positive in 4, which means it's negative in 2.
Okay. So is it just whatever is it?
Yeah.
Okay. And then, so how would I know if it's the person?
So if it tells you 2 things and they're both positive,
Yeah.
then it's got it. First quadrant's the only spot where I can have 2 things that are positive. Yeah, so just like write your TA before. Right, those always come back on Tuesdays. Yeah, that was maybe incorrect me to say. Yeah, I don't think so. They'll probably get back to 4 marks. But, yeah. Maybe just check the online part of the quiz. It has a similar example.
Of this last step.
Yeah, and the
So we can look at the online.
yeah, if you just go to like the quizzes on Coterminal, look at like submission.
Oh.
It'll show you all the.
Thank you.
So how should we do this?
I'm rationalizing the denominator. Oh, which means multiplying top and bottom.
So
Yeah, so in the bottom I get square root 3 times square root 3, which is square root 3 squared. And then the top. Sure. Oh, I'm still recording. Yeah, so what it wants you to do is similar to what I was doing in class, where I was breaking that number down with square number and square number. I just want to, but to give a hint on this one, all of these answers are going to simplify to like 1/2. And it's very cool. Yes. So likely what happened with the and then the negative has to be certain. A couple of questions in chat. Let's go see what's there. Yeah, we'll be uploading this lecture just as well. I mean, that's going to be fun for whoever's watching the video later. But yeah, hi from the end of class. I'm about to end the recording. But yeah, so this gets uploaded just as soon as the video finishes processing, which will take it a little while. And expect everything but the multiple choice questions on the exam, the written part of the exam, the in-person part of the exam. Yeah. Cool. All right, I am out of here.